So we want to find the principal moments of inertia and the orientation of the principal axes for this thing we did before. We know Ix, we know Iy, we know Ixy. We just plug and chug into the formula for the angle of the principal axes. What rotation of u and v do we have to get to find a principal axis? So we just plug and chug into the formula, Ixy over Ix minus Iy over 2. So there's the tangent. Two solutions. Remember two solutions? So we have the theta P1, or excuse me, theta P2. That was theta P2, theta P1. Okay. Probably about the, okay, let's go find the minimum and maximum now. What do you think, before we go on and do that though? So what does your instinct tell you that the low moment of inertia should be and the high moment of inertia should be? Is which axis is most of the mass furthest from? And I would say the u-axis. So I would say IU is probably maximum. And this is where most of the mass is around the v-axis. Because remember, it's mr squared. R squared has a big influence. The distance squared has a big influence. Most of the mass is near the v-axis, and it's furthest away from the u-axis. So I think u is going to be where I max is, and v is going to be where I min is. Next slide. So now it's just plug and chug. Plug and chug the numbers into the formula for I maximum, I minimum. I'd recommend you just draw the Mohr circle. That Mohr circle that we had earlier, you just draw that. All the formulas for everything can be found from just looking at that circle and figuring things out. Make sure you have an expression for the radius though. Okay, plug and chug, we get this expression for minimum and maximum. And now it's just number plugging and chugging. Here's what the author says. Maximum about the u-axis by inspection, most of the cross-section area is furthest from this axis. Basically, the author is saying just what I said. Okay. Now we're going to do this a little differently. We're going to look at the Mohr circle. How do we find the Mohr circle? Well, this is Ixy. Here's the origin, which is Ix plus Iy over 2. Here is Ixy. Here is the, the x-axis is the minimum, which we just figured out. Take that back. This has to be Iy. Iy 2.9. Ixy 3.0. Go negative here. Iy positive 2.9. Origin, Ix plus Iy over 2. And radius, well, we can figure that out. So from Mohr's circle, we ought to be getting very similar answers. I minimum, 2. We ought to be getting very similar answers. So here we go. Here's the Iy, Ixy, center, Ix plus Iy over 2. Let's see, constructing the circle. Let's see what the book talks about. So Ix is this, Iy is this, just like we found before. O is Ix plus Iy over 2. There we go. 4.25 from the origin, from this origin. Okay. Point A, and they used Ix, they didn't use Iy. The convention, a lot of books will put this point as Ix in the x-axis direction and Ixy up, and then Iy down at the bottom. Now, of course, if you get them flipped, what you'll get, if Ix is less than Iy, you'll just get this. You'll just have 2 points like this instead. Go figure, it's not too tough. The radius, then you can figure that out. And then you can get the minimum, Imax and Imin. Ix plus Iy over 2 minus the radius. So the maximum is the center plus the radius. Center plus radius. Minimum, center, minus the radius. What's the angle? Remember the, oops, that was kind of bad. I'm going to try to draw a better picture. So we had the triangle like this. Point O, point A, point B. We had the length of these. This would be negative Ixy, or positive Ixy if Ixy is negative. In this case it is. This point right here was, and I don't remember if we used Ix or Iy. I think the book uses Ix. It used Ix as the distance from the origin to point B. And then this, of course, is the radius that we calculated. Radius, right there. And this is the where on the x-axis the origin is. So it's real simple to get this angle here. Inverse sine of BA divided by OA. And yeah, that would be the sine of, that would be this angle right here. 114.2. That's twice theta. Just remember that. Twice theta. Divide it in half. 57.1 degrees. And okay, the principal axis. Now, it rotates. This rotates down like this. We are looking at the bottom. This diagram here is of the bottom left. So we just have, we're just switching to the top right to get our theta p, counterclockwise. Okay. And the v-axis is just perpendicular to the u. That's it.